We have been joined now by Sushil. Hello, Sushil, can you hear us?
Yes, I can hear you well. Can you hear me?
Yeah, hello and welcome. So now that in Europe we have been using PASCAL for like 3 years, and in the United States you rather have it in clinical studies. So can you tell me what are the most interesting points that you've seen so far with PASCAL? The key advantages, let's say.
Sure. Yeah, no, I think there's some important advantages. And, whenever you're choosing a device, you're trying to choose the best device for your patient. There's always pros and cons, and I think we have to consider it. And it's important for us to understand the anatomy. As you said, our experience has been limited in the U.S. It's been due mainly in clinical trials, the class 2D and 2F trials. Oops, sorry, my disclosure went by quickly there. Nothing directly related to Edwards or this device. So the PASCAL repair system, it's important in terms of key differences from the mitral clip system is that it's not a keyed system. It's 2 independent catheters that allows you a wide range of motion. There's this rail and stabilizer that allows you much better control than the original system did. And there will be ongoing continued improvements that we can talk about at some point. But there's a lot of maneuverability in terms of gaining height or getting coaxial and things like that. The other key difference, obviously, is the class. They're different in that they're a single row horizontally, and they're not aligned on the entire length of the grasper. This probably gives it a little bit more flexibility in some type of anatomies. And also, it's made from nitinol, and so it's in a closed position, and it's in its resting state. It wants to stay closed, and so because it's nitinol, there's some flexibility, and that again may help in some regards to valve area, as we'll talk about. There are 2 different devices. There's the PASCAL Ace and the original PASCAL. The wingspan in terms of where they grab on the leaflets and how much leaflet you need to grab is the same. You can see here the wingspan is 26. What the key differences are on the width of the device, 6 millimeters versus 10 for the PASCAL, but also in the width of the spacer, 2 versus 5 millimeters. But functionally, they're the same device. It's just the dimensions are different. And when you're going to a commissure chords or on the tricuspid side, it may play a difference. As we talked earlier, the elements are horizontally aligned, and the idea is that you're going to grab higher up on the leaflet, not at the free edge where it may be less robust tissue, but higher up. And this is sort of theoretical benefit, but in the orientation of the collagen fibers, so potentially have some advantages in terms of regards to retention. This is sort of the concept. This is pre-implant, this is post. You see the device here in the mid, and a similar concept. It's creating a double orifice valve here. The spacer is one of the unique concepts, and in addition to the spacer, and because it's nitinol and has some flexibility, the question is, does this give you some advantage in regards to valve area? I mean, one of the obviously drawbacks of edge to edge is you lose valve area. And this is sort of a FEA analysis, looking at leaflet stresses, but also looking at valve area with and without a spacer. Same implant, PASCAL without a spacer versus the PASCAL with the spacer. But theoretically, there's a little bit less stress on the leaflets, but importantly, there's the valve area in this analysis increases by about 20% during diastole, and that's due to the spacer, but also a little bit of the flexibility of the arms. And then, the ability to elongate, and I'm going to just go to the next slide, but the clip in a closed position, this is the leaflet capture position, similar to what we're used to. But if you get stuck in a case like this, especially in the medial cords, you can elongate. And I think that's important consideration. And this is an example, this is obviously not quite as medial, but say you don't like the position or you're stuck in cords. As you elongate, the retention elements are up top. And as you're withdrawing, the retention elements are not in the direction of tissue. So even if they're engaged in the valve, it should allow you to come out of situations where you're stuck. And this is that concept of getting more valve area because there is some motion with the nitinol elements in diastole. And you can see that in these animations. So those are some of the brief sort of advantages. I mean, I think these are theoretical, these are important, and in certain cases will provide some advantages.
Okay, thank you.